I don't think there's a specific spot in the parade so much. No, yeah. You're good? Homework questions? Yes. 12, 26, 48. I'm going to look at 48 first. So 48 is to convert 135 degrees, 10 minutes, 36 seconds into degrees. $35 degrees. 10 minutes. $135.1767. 48. So we'll go out 4 decimal places. 1.767. Yeah, 47 AB, and then you do the same thing for B. You can really just plug it in. The 30 or the graphing calculator will convert it for you. Yeah. 26. And 32. So it's asking where this angle lies in which quadrant. So B is the same thing. Well, with the negative angle, if we want to get the positive, we can add 360 to it. And if we add this, because we're adding 360 to get it back to being between 0 and 180. I'm not so focused on the 50 minutes because that's just a decimal. It's not going to make a big difference where it is. In the quadrant plane, 0, 90, 180, 270, and 360. Well, 228 is going to be over here, so this would be in quadrant 3. Because it goes 1, 2, bless you, 3, 4. So part A of 26 is the third quadrant. Part B is 3.4 degrees. Well, the 3.4 degrees would just be right there. Questions on 26? A is quadrant 3, quadrant 1. Not yet. 12 is next. We're ready to look at 12. Okay, I'm going to erase all this here. 12 is similar to what we just did. Negative pi over 6 and 11 pi over 9. We're trying to figure out which quadrant do these angles lie. Well, if we find it hard seeing it as radians, radian measure, we can always turn it to degrees and multiply it by 180 over pi. So it'll give us negative 30 degrees. Negative pi over 6 is the same as negative 30. So if we want to see what it is, because again, our coordinate 0, 90, 180, 270, and 360. This is 1, 2, 3, 4. Counterclockwise is positive, clockwise is negative. So if we talked about this in a negative direction, well, this would be negative 90. This would be negative 180. This would be negative 270. And all the way back around would be negative 360. So one way we can see negative 30 degrees would be down here in the fourth quadrant. Now, if we added 360 to it to find the coterminal angle, it'll tell us that it's 330 degrees. Well, 330 degrees would also bring us to the fourth quadrant. Does that make sense? Because that's all it's asking. Where is this going to lie? 11 pi over 9. The times pi over, yeah. Well, we can do it in the calculator. We can do it by hand. Because pi and pi will. What's 180 divided by 9? How many times does 9 go into 18? 2, so 20. 20 times 11. So 220 degrees, where is that going to be?
This is the final announcement.
180 to 270.
For SCCLA, all students come to Miss Hopper's class.
So it's in the third quadrant. It's just figuring out where they're going to lie. So 18 divided, 180 divided by 9 is 20, yes? 20 times 11. Because even the one before here, pi and pi cancel. 180, 18 divided by 6 is 3, so 30. Yeah, because even when you type these in the calculator, here, if we have pi, we know that the pi cancels. So I could have just said 180 over 6. Or here the pi cancels, so we can say 11 times 180 over 9. Because the pi is going to go away. So that's it. Yeah, so that gives you, so pi over 6, I think this is negative, isn't it? 15. So coterminal angles, so pi over 6, so you added it, pi over 6 plus 2 pi gives us one coterminal angle. Now we can also take it minus 2 pi. You just need your minus sign. Yep. So we need one positive, one negative. Now if we said that one of them was 27 pi over 6, I can subtract 2 pi, and I get 5 pi over 2. I have a positive. Well, I'm going to need to subtract 2 pi from it again. I get pi over 2. That's still a positive. Okay, now I've got my negative. So sometimes if it's a really big positive angle, we might have to subtract it multiple times to get where we want. So we have the positive negative. So degrees radian, we're just going from degrees radian. If it started off as a negative radian, it's going to be a negative degree. Because to go from degrees to radians, we multiply by pi over 180. Radians to degrees, we go 180 over pi. So Actually, so that exact keystroke, except instead of the numbers. So that string right there. So enter, then put your minutes, whatever that is, down, because then that gives you the minutes. Number, second, 0. Go up to the, because you should see one. Yep. So that is one of the things, if y'all haven't noticed this, especially if you're rewatching the video, underneath the screen for this here, that there is the key log. So it logs out every key I hit so that you can go back and look at it. Now, the only time it becomes an issue is not so much if I don't clear it. If I don't clear it, it's just going to log everything. If I make a mistake and have to redo it, it will keep going. Does that make sense? So it is a nice thing every now and then that you can go back and look at that. Question?
Yeah.
P2.
You want to go to that. Who's the boy? It's Cooper. Sorry.
You're good?
You're like Spider-Man. Alex in there?
Luckily, we didn't do all of chapter P right there.
Okay. And then 100. That one?
Yep. Because you asked about that, I think, the other day, yeah?
Did I? Oh, was it on... Is that the answer?
Let's see here. Yeah, so... No, you're
Oh,
good.
sorry.
You're good. So 100. So we can put both sides to the 2/3.
Oh.
So x squared minus x minus 22 is equal to 9.
Just plug that in first.
Then we add the 9 to both sides, or subtract the 9 from both sides. Now you're going to have to use
You add the 9 or subtract?
subtract.
Oh, right.
You're going to have to plug it into
Okay. I can do that.
quadratic formula, because unfortunately we get irrational solutions. And part of that's because if we tried to factor it, we need factors of 31. 31's prime. So there's no way to get negative x. All right, guys, we can do some more of those at a later date. But what we're looking at today is 1-4, our new note sheet. Now, definition of trigonometric function of any angle. Let theta be an angle in standard position with x comma y as a point on the terminal side of theta. And r is equal to the square root of x squared plus y squared. That's just distance formula. Or really, we could say Pythagorean theorem also. So tangent is equal to y over the length, or hypotenuse. Cosines x over r. Tangents y over x, cotangents x over y. Secants r over x, and cosecant is r over y. So by this here, we can find sine, cosine, tangent, secant, cosecant, and cotangent from this here. And really all of these here I would graph the point. We don't have to be specific or have it exact, but -3, 4. This point here, -3, 4, is going to be in the second quadrant. And what we can do with that point is we can make a triangle. Because we're used to triangles, used to using triangles, and this triangle will help us find these values. Now the x value, the distance we traveled here is -3. the distance up the side is 4. Now we are used to having distances as positives, but we will leave the x as negative because we're up -3 on the x, +4 on the y. It'll help us get the correct sign with our sine, cosine, and tangent. Now the last thing we need to find is our r, the hypotenuse of this here. Now r, by definition, is the square root of x squared plus y squared. Or in our case, -3 squared plus 4 squared. We could also use Pythagorean theorem to get there. A squared plus b squared equals c squared. 4 squared plus -3 squared equals c squared. Now at this point here, everything on that side is a number. So 4 squared plus -3 squared is 5. Which is telling us that this is indeed a 3, 4, 5 right triangle. Now by the previous slide, sine is going to be the y value over r, opposite over hypotenuse. Well, that would be 4/5. Cosine would be what? Almost. Well, I think you're talking about cosecant. Cosecant would be the flip 5/4. Cosine would be, because the cosine's adjacent over hypotenuse, so that would be -3/5. All right, guys. So secant 1/cosine. So this here would be -5/3. Tangent. There's two different ways we can get to tangent. Tangent is going to be the opposite side over the adjacent, the y over x. So the y value is 4. The x's value is -3, so it's going to be -4/3 for tangent. The other way we can get to it is sine over cosine. So sine's value is 4/5, cosine's -3/5. In the calculator, we can do 4/5 over -3/5, which is -4/3. It gives us the same value. And the last one, cotangent, is x over y, or just the flip of tangent, which would be -3/4. Yes? You can have it on bottom, top, or in front. We just need it in one of the places. Yeah. Yeah. Yeah, right there? Yeah. Because we don't normally leave it in the bottom of the fraction. We normally either put it to the top or in front. Yeah. That's it. It didn't really ask for secant, cosecant, or cotangent, but once we get sine, cosine, tangent, it's not hard to get the others. Questions on this here? Now this next part, we do have most of this on the unit circle, because the unit circle does have all this information of where our points are. In the first quadrant, x and y are both positive, because we're in the positive x, positive y spot, and the angle is between 0 and pi/2, 0 and 90. Quadrant 2, x is negative, y is positive, between pi/2 and pi. Quadrant 3, both x and y are negative, and we're in the angles between pi and 3 pi/2. In quadrant 4, the x value is positive and the y value is negative. That's really, this is just rehashing how to plot a point with the x, y. And we're between 3 pi over 2 and 2 pi. We also have this over here that for quadrant 1, sine, cosine, tangent are all positive. That means also that cosecant is positive, secant's positive, and cotangent would be positive. Because if sine's positive, cosecant's positive. If cosine's positive, secant's positive. Tangent's positive, cotangent's positive. They're going to go hand in hand. So here, cosecant's going to be positive, but secant's negative and cotangent is negative. Quadrant 4, cosecant's negative, secant's negative, but cotangent is positive because they kind of are assigned to which ones they have. So that's when cosecant's negative, secant's positive, and cotangent is negative. Because if one's positive, its reciprocal one is also going to be positive. Questions on this here? Okay. We'll finish this tomorrow. We'll pick this up tomorrow.